Okay, so we're going to talk about deductive reasoning today. Our goal is to know how to use symbolic notation to represent logical statements, also to form conclusions by applying the laws of logic that we're going to talk about for true statements. So when we use logical argument in geometry, we're using what's called the deductive reasoning. This is different than the inductive reasoning. Inductive reasoning, if you remember, use patterns of pictures or things that we see in terms of numbers or anything like that. But deductive reasoning uses facts, definitions, and accepted properties in a logical order. So we're going to use the theorems and postulates and things like that, and also definitions of vocabulary words to use logical statements in logical order step by step. So then most of our proofs and what we do for the rest of geometry, we're using deductive reasoning compared to what we talked about before with inductive reasoning, which is just using patterns, right? So then let's talk about deductive reasoning. And the first thing we're going to do is talk about symbolic notation. So I think some of you asked before about whether there was symbols to represent the conditional statement if then, and the biconditional statement if and only if. Yes, there is. And so instead of writing the whole thing, we can use symbols like this using P implies Q with the arrow there. And this is Q implies P. So this is like the if and then statement. So another way to read this is if P, then Q. This will be if Q, then P. So this will be converse of each other. So notice the P and the Q is switched here, right? So that's the hypothesis and the conclusion being switched, right? So here, if I were to rewrite this as a sentence, because P is same thing as the value of X is 7, and then Q is same thing as X is less than 10. So if I write P implies Q, or if P, then Q, that would just be rewriting, instead of P, you just replace that with the phrase there. So it'll be if the value of X is 7, then X is less than 10. So that's if P, then Q. P implies Q. The converse of that would be Q implies P, or if Q, then P. Just switch the hypothesis and the conclusion. So that would be if X is less than 10, then the value of X is 7. So just switching the hypothesis and the conclusion. So if they're both true, then you write the biconditional statement. This is if this is P if and only if Q, right? So if you see the double arrow there, that's how you write the biconditional. So that would be replacing the if and only if phrase for the biconditional. Remember that was the magic phrase for the biconditional. So this is biconditional is true, but the converse is false. So that therefore the biconditional statement P if and only if Q is actually false. So remember both the statement and the converse have to be true in order for the biconditional statement to be true. So the double arrow is the biconditional. The one arrow is the conditional statement if P then Q, or if Q then P. So that's the symbols that we use for the conditional statement as well as the biconditional statement. So you can actually write the inverse as well using the symbol here. So that little kind of a wavy line there or a little wiggly there, that is the symbol for not. So that's the inverse or the negation, right? So the contrapositive would be to switch the P and the Q, because that's the converse and the inverse together. So the contrapositive of P implies Q, or if P then Q, would be switching it. So notice the Q is first, and then put a not in it. So this will be if not Q, then not P. So that would be not P. So this will be not Q implies not P, or you could read it if not Q, then not P. And then you would just replace that with the phrase that's given to you here. right? So the inverse of P implies Q, or if P, then not Q, would be just putting a not in it. So put a not, so that'll be if not P, then not Q would be the inverse. And you could replace that with words there, right? So then here, you put a not in there. So if it is not 8 p.m., then my favorite TV show is not on, right? So that is the symbol for the not right there, right? So the inverse, put a not in there. So my favorite TV show is not on, then it is not 8 p.m. So that is not P, then not Q. You could also read it as not P implies not Q, right? And then you just have to replace the phrase instead of P and the Q. That's it. All right, so those are the symbols you can use to write if and then statement as well as biconditional statement. So here is our first logical law, which is called the Law of Detachment. Now we have another law we're going to take a look at. It's called the Law of Syllogism. And they are a little different and they are a little confusing. So make sure you remember the name and what it means and how you apply it. So I gave you some example here. So law of detachment says that if I give you a true statement, if P, then Q, so P implies Q. And if I give you a statement about the first part, so that's the important thing here, right? So I have to start with the hypothesis. And if I tell you something about the hypothesis, then you can conclude something about the Q, which is our conclusion. We can't go backwards. So I have an example here, like, the sentence that you're familiar with. So if you are in Mr. Park's class, that's the P, right? Then you are really smart, that's the Q, right? And then I say something about the hypothesis, which is you're in Mr. Park's class. So then I give you an information that this person, Joe, is in Mr. Park's class. Well, since Joe is in Mr. Park's class, and that's something about the hypothesis, the P, then I can conclude something about Q. And in this case, Joe is really smart, right? So that is using the law of detachment in proper order. Now, however, you can't go backwards. So if I had said, Joe is really smart, you cannot go backwards and say and conclude that Joe is in Mr. Park's class. So law of detachment only works from P to Q. It doesn't go backwards, right? So be careful with that because a lot of people get confused with that. So notice I start with an information about the P, which is the hypothesis. So say something about the fact that you're in Mr. Park's class. So I am telling you that Joe is in Mr. Park's class. So then you conclude Joe is really smart. Can't go backwards. All right. So let's see how law of detachment works. A couple more examples here. So here, if I tell you if Rogers gets a part-time job, that's the P, then he will buy a new bicycle. So that's the Q. That's the conclusion. That's the hypothesis in the front. But then notice what I'm telling you first. Here, I'm giving you the information that Roger buys a new bicycle. Now, is that information about the hypothesis or the conclusion? Well, that's the conclusion about buying a new bicycle, right? So you can't go backwards and conclude that Roger got a part-time job. So even though it might sound like it's the same thing, that's not how the law of detachment works, right? Law of detachment always goes in one direction from P to conclude Q. You can't go backwards from Q to conclude P. That's not how the law of detachment works, right? So that is actually invalid usage of law of detachment, right? So that is not a valid use of law of detachment because you're going backwards from Q to P, right? So you have to go from P to Q, all right? That's a little bit confusing, but you need to make sure that the order is correct. So the second part is correct here. So notice that the P is two angles. If two angles are vertical angles, then they are congruent. So that's the P that I circle. So you have to start with that information, something about vertical angles. So notice I'm telling you that angle 1 and angle 2 are vertical angles. So notice I'm starting with the information about the P, about the hypothesis here. So therefore, you could conclude the Q, which is the conclusion part, that angle 1 and 2 are indeed congruent. So that is a correct usage. That is a valid usage of the law of detachment, right? So law of detachment only goes in this direction from P to Q. So P implies Q, not the other way around, right? So make sure that law of detachment works in only one direction from P to conclude Q. You can't start from Q and then conclude P because that's going in the wrong direction. All right, so that's how the law of detachment works. Now, so here's a few more examples that you can practice writing. So you can write if P, then Q, and then if Q, then P. So that will be the converse of this. And then this will be the contrapositive. So you switch it, put a not in it. So this will be if not Q, then not P. And then this will be the inverse of number 1. So if not P, then not Q. And so you just have to substitute with the stereo is playing for the P, and then I am wearing headphones for Q. So you just write the sentence from that. Now, number 5, here is the if part. So that's the P, the if two adjacent angles form a straight angle, right? And then the angles are supplementary. So that's the Q, that's the conclusion. So I have to tell you something about two adjacent angles forming a straight angle, right? But this one, notice I'm telling you first. I tell you that 1 and 2 are supplementary. So I'm not telling you information about the hypothesis. I'm actually telling you information about the conclusion. Well, that's going backwards, right? So I cannot conclude you can say that the angle 1 and 2 are adjacent. That's going backwards. So that is not true. That is not usage, not a correct usage of law of detachment. So this is not valid, right? Of usage of law of detachment. You can't go from Q to P. You have to go from P to conclude Q. This is going backwards, okay? So here are the words for that. And then this is not a valid usage of law of detachment. So that's a little bit tricky. You can't go backwards, right? You always have to start with P and then conclude something about Q, all right? Now, the second law is what's called the law of syllogism, which is different than law of detachment. So law of syllogism is actually comparing three things or three statements here, three phrases. So we have if P, then Q, right? P implies Q. However, I give you another statement here, starting from Q, implying R. So notice I'm going from P to Q, and then Q to R. So I'm comparing three things here, right? So if that's the case, then if they're all true, and they have to be all true, right? If they're false, obviously it doesn't make sense. But if they're all true, then you could imply, you could conclude from P to R. So you can skip the Q in the middle to make a true statement using a law of syllogism, right? So that's a little different. And this one is going to have if and then statement in there. So that's another thing you can kind of tell how you're using the law of syllogism. So you're making jump from one statement to another statement. So here, something again you're familiar with. If you are in Mr. Park's class, then you are really smart. So this is P implying Q, right? And then I start with Q. If you're really, I kind of color coordinated here. I don't know if you can see. So if you're really smart, which I said here, that's the Q, then you will go to a great college. So that's the R. So then I can skip the Q part in the middle. You're really smart in the middle. And I can start here and conclude. If you are in Mr. Park's class, I can skip over to the end and then conclude, then you will go to a great college, right? So that is another true statement I can say about you, right? That if you are in Mr. Park's class, then you will go to a great college. And I said that skipping the part about you're being really smart. And that's using the law of syllogism when you're making a connection between three, phrases or three things by making a jump in the middle, because that's the same thing in the middle. All right, so let's take a look at how law of syllogism works. So here I have a whole bunch of statements here, 1 through 5, and you could make a lot of true statements based on law of syllogism by jumping from one statement to another statement, right? So here are 3 true statements you can make. Let me show you the answers here. So if I start with if a cat lives in a pride, so here is if a cat lives in a pride, then it is a lion. But then I look for a lion right here, right? So I skip the lion part. And so if a cat lives in a pride, then it is a lion. If it is a lion, then it weighs 400 pounds. So notice I'm making the jump from the beginning to the third part by skipping the lion part. And so that is using a law of syllogism when you're making that jump to skip the same phrase or sentence in the middle, right? Now this is second one is going backwards, so that might be a little bit more tricky there, but we are starting with then it is a tiger. So notice it is a tiger, then it is a tiger is here, right? So then if a cat weighs 650 pounds, so look for that somewhere else. So then it's right here. So then notice here, I'm making a jump from 650 pounds to conclude that it is a tiger. Well, then I can start with this. If a cat is the largest cat of all, then it weighs 650 pounds, but I can skip that and to conclude that it is a tiger. So you could go, filling in the back or filling in the front, which is a little more difficult because you got to kind of think backwards. But after you write it, you can see if that it skips the middle part, which is same, and then makes the conclusion from the first part to the third part. So you're going from A to C, skipping the B, or P to R, skipping the Q in the middle, right? So that's using law of syllogism. Now, another thing you can do is notice on the last one here, it actually makes a jump several times. So if a cat is the largest cat of all, so it starts here, and then it goes to, it can weigh 650 pounds. And then it has 600 pounds, and then it is a tiger, right? However, instead of saying it is a tiger, which we already did, I can make another jump. So here is, if it is a tiger, then it hunts alone. So notice I'm making several jumps. So I can do that as well using the law of syllogism. So you could not only jump once, but you could jump twice or even more if you wanted to make another conclusion, starting from A and skipping B and skipping C and then going to D. So if A, then D. So we're skipping 2 things in the middle here. So you can do that as law of syllogism as well. Okay, so that's how we use the law of syllogism to make another if and then true statement by jumping around. Okay, so here's another practice. You can make a whole bunch of statements, true statements, using all the statements here by making connections. And so you can make a couple of statements like this, right? So if an elephant lives in India or Southeast Asia, so you start with this, right, which is here, right? So if the elephant lives in India or Southeast Asia, then the elephant is an Indian elephant. But I can make a jump because if it is an Indian elephant, it can weigh up to 3.5 tons. So that's why I'm making a jump from here to here skipping the Indian elephant part, right? So that is using the law of syllogism, right? So another statement I can make is that if an elephant lives in Africa, so then we start with, let me erase this one here. So we start with if an elephant lives in Africa, which is here, right? And we know that it is an African elephant, but we can jump from an African elephant to saying that it can weigh up to 8 tons, right? So we can go directly from if an elephant lives in Africa, skip the part about African elephant, and then just make a conclusion that if it is an elephant lives in Africa, then it can weigh up to 8 tons is another true statement you can make, and that is using a law of syllogism. All right. So law of syllogism basically makes another if and then true statement by jumping around or jumping things around as long as they are same thing in the middle. Right. So that is the logical argument that using the either law of detachment or law of syllogism. So that's the homework. Okay. Thank you very much.